Hi, my name is Victor. This is my first video on my YouTube channel of the Victor Learning Hub. So I really hope you guys enjoy this video. Yeah, let's just get straight into it. So I just thought, we'd just do some matrices today. This is specifically this question here we got is from the Year 11 Specialist Math textbook from Jacaranda. And this question is focusing on matrices, obviously from Unit 1. Awesome, so let's get straight into it. Solve for x and y using inverse matrices. So it wants us to use inverse matrices to solve for the following simultaneous equations of 3x minus 4y equals 23 and 5x plus 2y equals 21. Okay, cool, awesome. So what do we do here? What do we do with the information we've been given? Obviously, it's asking us to use inverse matrices. So that means for our calculations when solving these simultaneous equations using matrices, we're going to be obviously using an inverse matrix. So how do we transform, how do we mathematize this into matrices? So what do we do? So I think it's important to just refer back to the general formula hopefully you've learned in class, which is AX equals B. Now, AX equals B, A represents the coefficients of the X and Y variables. X represents the variables. So X and Y, that's what it represents. And B represents the equations, I guess answers you can say, which is 23 and 21, which we have right there. Okay, great. So let's try and format these simultaneous equations into matrices as part of AX equals B that we can use to solve X and Y. We need to think about the multiplication of matrices here. Multiplying matrices. Because we obviously know AX, it's the multiplication, matrix A multiplied by matrix X. So what you need to do is format your A matrices first. So your A matrices should look like something like this. 3, -4, 5, 2. So it doesn't make too much sense as its own, but let's add in the X matrix, which represents the variables of X and Y. So X, Y. Okay, great. So now you just need to think, does this actually work? And you can just try and test it out when you're writing down and trying to solve the question. So we know that 3 is going to be multiplied by X, so that's 3x up here. -4 is multiplied by y, -4y is here, so that matches. 5 multiplied by x, that matches here. 2 multiplied by y, that matches here. So that works, So these matrices are multiplying to represent this these simultaneous equations. And just for ease, we'll just name equation 1, equation 2 for each for those equations. Okay, so now we want to get B. So B should just be the equation's answer. So that should be 23, 21. Okay, great. So AX equals B, that's going to be our answer. Not our answer actually technically yet, but we're going to get there using these matrices. So let's just go back to our initial formula, AX equals B. The AX equals B. So we are solving for X and Y as we usually do in math very often. So how am I going to basically isolate this matrix? How am I going to use these other matrices using the knowledge I've learned with matrices to just find X and Y? So first of all, it comes down to actually deconstructing this equation and getting the X matrix to be isolated just by itself. So what you need to do is something called pre-multiplying. Now, pre-multiplying, all you're doing is you're multiplying the inverse of the matrix. So a to the power of -1, the inverse of a, multiplied by a of x, multiplied by x still equals the inverse of matrix A multiplied by B. Make sure that you have the inverse of matrix of A on both sides, because else the equation will not stay the same, obviously. Okay, so then it just comes down to that simplification, obviously. It's because we know that the inverse of a matrix multiplied by its matrix, that will be the identity element, and that's going to be multiplying by x, and that's going to be the inverse of matrix A multiplied by B. Still, nothing changes on the right side. Okay, now we know that the inverse of a matrix, all right, the inverse doesn't change the value of the matrix. So what we can do is actually just say x equals the inverse of matrix A multiplied by B, because the identity element multiplied by the matrix X doesn't change anything. That's why we did this multiplication over here, so we could get to this X here, mainly to get the identity element first and get this X here, and overall show all this important working out through our algebraic skills. Let's see. Okay, great. So now all I want to do is find my new matrix A to the power of -1. So that is what I'm going to be focusing on. So what I do in the exam, unless if it asks you to show full working out, just jump to using the graphics calculator. So I'll demonstrate here using the Casio Graphics Calculator I have on my screen here. So what you want to do is actually go back to matrix A first, because we're finding inverse. So matrix A is 3, -4, 5, 2. So we want to add matrix A into our graphics calculator. So what you want to do is press F3, and then we've got matrix A here. So, and then we want to make sure we put in the right dimensions for matrix A, which is a 2 by 2 matrix, so 2 and 2. Press execute again. All right, now just input the numbers here. So we got 3, -4, 5, and 2. Okay, awesome. And now we are multiplying by matrix B. So let's input matrix B into the graphics calculator. So we know matrix B is a 2 by 1 matrix, so making sure we account for that. So that's going to be 23 and 21. Okay, great. So just using the graphics calculator, all you're going to be doing is pressing options, and you want to go to matrix / vector here, and you want to put a bracket, so get your first bit of your bracket, matrix, so using F1 to press matrix, then alpha, so we can use A, because we put the matrix in the A slot. Put another bracket, use this arrow here for a power, to the power of -1, which is an inverse. So this is going to be the inverse of matrix A, which is 1 over 13, -5 over 26, 2 over 13, and 3 over 26. Okay, great. And then we've got to multiply by B, which is 23 and 21. Now we can just put this into our graphics calculator to find the value of X, the matrix X itself. You can either do shift answer here, because you've already got matrix, the inverse of matrix A here, or if you want to be safe, you can just input it again in terms of bracket of matrix alpha A. So you're just copying and pasting the same thing you did above. All right, now you want to go to the right, and you want to multiply by matrix B, because we have matrix B here. And we already inputted that. So matrix alpha B. Okay, awesome. So that means, therefore, X, matrix X is going to be 5 and -2. We're going to refer back to matrix X here. That's our X and Y, obviously. So we can just input that in here as well, because 5 -2 is going to be X and Y. So hopefully that clarifies any conclusion, because obviously these correlate together. So that means, therefore, X is 5, Y is -2. Okay, awesome. So we have done what the question is asking for. So I'm just going to do a little bit extra step in terms of evaluating the reasonableness of your solution. Evaluating the solution's reasonableness. So part of your internal assessment for your mathematics exams, there is a part which says evaluate the reasonableness of your solution. It is mainly more tested in the PSMT. However, teachers can still sort of implement into the exam here and there a little bit to try and test that certain criteria. So evaluating the solution's reasonableness, if you get something like this in the exam, all it's asking you to do is actually just to do a check. And what we mean by a check is actually subbing in the x and y values into either one of the equations, so equation 1 or equation 2. So we know that equation 1 is 3x minus 4y equals 23, so let's go back to that. 3x minus 4y equals 23, and all I'm going to do is get these values here, and I'm going to sub it in here. So 3 multiplied by 5 minus 4 multiplied by -2 is 23. 15 plus a is 23. 23 equals 23. So this proves that our solution is reasonable. We do a tick. We can make another statement at the end. Therefore, the solution is reasonable because we've subbed in the values to prove that they're actually valid, they are accurate, and they work in the equation. You can do the same for equation 2 as well, but usually, generally, if you do it one time, usually that's enough already. All right, thanks for watching.